Hi, this is Miss Webb. This section, we're going to talk about being able to describe and interpret data distributions in terms of its shape, its center, and the variability or spread. We're not so much interested in the exact calculation. The math can be done on a computer, it can be done on some calculators. I'm more interested, can you interpret the data? Can you look at the graph and kind of see approximately where it is? So it's, like I said, it's more important, can you interpret the data? Okay, let's go get your notes out. And I want to go over some terminology with you. When they talk about the mean, you know, in 6th and 7th grade, the mean was the average. You add up all the values, divide it by the number of observations you have. They're going to talk about it saying, where's the center at? So if you have a data distribution, where's the center at of all that data? Or they could talk about what's the fair share value. It should represent the balance point of the distribution. Okay, and the sum of the deviations to the left should be equal to the sum of the deviations to the right. And you want to think of it, here's another way, I'm just coming up with different ways to think about an average or typical value for a data distribution. What's the average? That's the one that you're familiar with. For all the values, what's the average for the data distribution? They use the term center. So what's the center of the data distribution? Okay, they also talk about the standard deviation. A lot of times they use the word spread. Okay, it's the measure of the spread or the variability in the data distribution. You can also think of it as how far off, what's the deviation from the mean. Okay, and I wanted to show you this one. This one up here, there's 4 different little graphs up here. This one right here is the amount of time these students spent studying. They already know the standard deviation is 8.77. They're looking right about in the middle is at about 42. So they tell you the mean is 42, standard deviation is 8.77. And what they're looking for right here is you have data set A, B, and C. Okay, if that standard deviation is 8.77, look down at set B. Aren't they a lot closer together? That means their standard deviation would be smaller than 8.77. And then look at C. C is a little more spread out, so it's going to be a little bit bigger. And look at A. It's really going to be a lot bigger than 8.77 because the spread is much bigger. And that's what they're looking for here. In your notes, it tells you exactly how to derive a standard deviation, and you can look at that. But like I said, I'm not interested in this lesson on having you exactly determine the standard deviation. I want you to be able to interpret it. Okay, the standard deviation. Another way to think about it is a small deviation indicates the data points tend to be very close together. These are all close together. That would be small. A large deviation, boy, here's a really big one, indicates that the data points are spread out over a larger range of values. Okay? Okay, distribution shapes. A lot of times they're going to talk about, is it symmetrical? Okay. And the left side and the right side of the distribution are roughly mirror images of each other. So if I take my paper and I fold it in half, they're mirror images. They talk about a mound with a single peak. That's how you might describe a data distribution. Another way to describe it would be, is it skewed to the right or skewed to the left? And what you want to think about there is a tail. So you see how this one's kind of got a tail and it's a lot longer over on this side than over here. So it's skewed to the right. Look at this tail. It's a lot longer over here than it is over here, right? From the mean. So it would be skewed to the left. Okay. Okay, so now I want to go through the examples and the exercises. I need to remind you of something that they say you're supposed to know, but I don't remember going over this with my Algebra 1 students, so I want to talk about it. Okay, the heights of the bars on a relative frequency histogram represent the proportion of the observations within each interval, not the number of observations. And I'm going to show you that in the questions how that works. They want to know what's the height of each bar. Or I'm sorry, the width. That should be the width is the question that is on your exercise. What is the width? The width right here is 5 and it's in hours. 5 hours. Okay, and let me write that down so I can correct the slide for next time. Okay, so now let's talk about what does the height represent. Okay, that proportion, and that's where this proportion comes in. It says the proportion of all batteries with a life in the interval corresponding to the bar. For example, approximately 0.05%, there's 0.05%, okay, of the batteries last between 85 and 90 hours. So you would say, well, 5% of the batteries in this distribution have a battery life between, what is it? Between 85 and 90. Between 85 and 90. Okay, would you describe the distribution of battery life as approximately symmetrical or as skewed? In this particular case, I'm going to think about the mean. Let's answer this one down here. What do you think the mean distribution is? Is it closer to 95, 105, or 115? Okay, 95 would be over here. I think that is too low. Okay, so I don't think I would go with 95. Okay, let's look at 105. 105, that looks about right to me. It's right about in the center. And 115, well, that's a little bit too close. I mean, then you have the values over here are much bigger than the ones over here. I would go with that 105 if I was going to approximate the mean. Okay, it's about in the center. Okay, if you want to describe the distribution as approximately symmetrical or skewed, here's my mean. Okay, here's one side. Here's the other side. It's not perfect, but it's pretty much, it's a mound. You don't have one big tail going off to one or the other. So I would say, yes, I think that's reasonable. Okay, so again, I'm really interested in if you can interpret the data and give me some approximations. Okay, let's go over some of the other questions they'll ask you when you're looking at this. Okay, now they want you to think about the standard deviation. And they want to say, okay, if we have the mean at 105, okay, so here's 105, right here is my mean. Okay, is 5 a reasonable description of a typical distance from the mean? Well, a typical distance, they're a lot bigger than that. Than 5. 5 is not, that only covers those other two bars. I would say no, it's too small. Okay, now let's look at 10. If I talked about 10, here's 105. Are most of them about 10 away? Well, there's those that are 10. There's those that are 10. That is the majority of the data. I would say, okay, it's reasonable. It's an approximate. I would go with that. How about 25? Okay, well, are most of them 25? The distance from here, is it mostly 25? 25 is way, let's see, if this is 105, it's way over here. I don't think that's typical. I think it's too big. I think that the 10 would be a reasonable description of a typical distance from the mean. Okay, here's another one. This is the one talking about the roller coasters. And it talks about the maximum drop and then the relative frequency. So the roller coasters they looked at, these are the proportion, 20, let's see, let me get one. 30% of them have a maximum drop between 90 and 130. Okay. Now, if I wanted to look at this shape, let's see, I'm going to start here and look, I got a tail going way over there. I would say that this was skewed to the right. Okay, now if I want to talk about an average, let's look. It says, okay, is this the average 90? No, I think that's too far over that way. I want it to be about in the center. Look at 135. Okay, remember the distance between here is 40, so they're saying about 135 is right there. Did you have the same number over here? I'm thinking that looks pretty good. 240 would be way over here, and you have a lot more data points over here than you do over there. So I'm going to say 135 would be a good approximation, at least better than 90 or 240 for this data distribution. Okay, is the standard deviation of the maximum drop distribution closer to 40, 70, or 100? Wow. Well, if I do select 135 as my mean, and I look at the distance between 135, notice the distance here is 40, distance here is 40, distance here is 70, distance here is 70, and then 100 and 100. Okay, so if I want to say what the standard deviation is, a typical, you can think of what's a typical distance between the mean. I'm not going to pick 40 because that's not a typical distance. That's pretty close. I'm not going to pick 100 because there's not very many that are 100. But if I look at 70, where's 70? I got this, I'm right there and right there. On this one, I think I'm going to pick 70. It's about in the middle. Okay, let me go back to my notes really quick. Let's see if they picked that too. Let's see. Yep, they did as well. But you want to think of, they try to give you these numbers here to tell you, okay, here's 40s way down here, 40s there. 70, I think it's got, the average or approximate distance from the mean. I would pick 70. It's about right in the middle. Okay, now they give you this one too. I like this one. This one's kind of fun. It says, okay, we're gonna talk to you about, we're gonna describe it. We're gonna tell you the shape. We're gonna tell you the mean, and we're gonna tell you the standard deviation. Okay, and they want you to pick what data distribution goes along with this. Now in these, the first thing I'm going to do is, okay, well this shape looks pretty symmetrical. This one's not too bad either. Look at this one. It's way skewed to the right. This one's way skewed to the right. So I know this one is got to be A or D. A or D. This one would have to be A or D. Right? Because here it is, skewed to the right, skewed to the right. And these are mound shapes, so this has got to be B or C. And this one would have to be B or C. Okay? So B or C. So now let's keep going. It says which one, let's look at these over here, the A or the B, the ones that's A or D. There's A and there's D. We know they're both skewed to the right. They say the mean is about 100. So they're saying the mean here is right there. And down here, let me make sure I got this right. Ooh, this means about right there for that mean. Okay, that's their mean, what they're saying the mean is. One of them, and they're saying they're both the same, so they just gave you the mean. It can only be 100. But they want to talk about the standard deviation. So this one has to be A or D, and one of them has kind of a low standard deviation, and one of them has a high one. Okay, well this one is spread out quite a bit. This one's closer together. So this one would be a low standard deviation, and this one would be a high because the spread is higher. Okay, so this one would have to be D. We've narrowed it down to D, and this one would have to be A. Let's look at this one. We know the mean is at 100. Know the mean's at 100 here. And this one, it says, okay, one of them has a very low distribution, standard deviation, and one has a high. Which one has your data sets closer to each other? Okay, so I think, see how this one's spread out a little bit further than this one? These are a little bit closer. So I would say B has to have the lower standard deviation. So I would think this has got to be B. This one's spread out a little bit. It's spread out further. The data is spread out more. So I would say this one is C. Okay? You see how I did that by kind of a process of elimination? Okay. Now these are one of the last two exercises that they give us. And they're going to say, okay, when you have a data distribution, can you talk about the shape? Tell me where the center is. And can you tell me about the spread? Okay, so let's look at the very first one. The very first one, well, I always want to figure out the mean first. And the mean is probably, I'd say about, let's see, about 25 right in here. Isn't that about in the middle? I would go that for the mean. Okay, or the center. Okay. So if that's there, I would say that I'm going to say the tail, to the right. It's a little bit skewed to the right because the tail over here is a little bit longer over here. It's not a nice mound. It's a little bit skewed this way, not a lot, but I would say it's a little skewed to the right. Okay. And I'd say the center is about at 25. Now the standard deviation. So what is the typical distance between 25 and each of these guys? I mean, here the distance is 5. Distance here is 10. Okay, look over here. The distance here is 5, 10, 15, 20. 5, 10, 15, 20, and 25. So I'm going to say an approximation is the majority of the distance from here is at about 10. So my approximate spread or standard deviation, the majority of the data is typical distance, I'd say, is about 10. So I'm going to say it's approximately 10. Okay, when I get to here, it's not a perfect mound, obviously, but it's not really skewed to one side or the other. So I am going to say, well, it's approximately symmetric. It's not perfect, but I don't see it being skewed to one side or the other. And I'm going to say, I mean, this can vary, but if I look at the center, I'm going to estimate around 89 here. That's my estimate for the center. That's without going in and exactly doing the math. That's just by a ballpark by looking at about half of them are over here and half of them are over there. Okay, if I want to look at the standard deviation, these are 4, distance of 4 here. 4, 4, okay, and this one's another 4. Well, so that would be an 8. This one's an 8, 12. I'm not going to say, normally on the other one we pick like an 8 because you have quite a bit of data still over here and quite a bit of data over here. So I'm going to say my approximation for the standard deviation is about a 10. And that can vary. You're just giving an approximation. Okay? Okay, I think that's the last slide. So good luck with your assignment. It's pretty small. So good luck on that one. Thanks.